can you walk us through how AI is transforming software development, specifically coding, DevOps, QA, and then any other areas you want to talk about?
Sure. So AI is right now getting into a lot of these areas. And primarily, if we look at software development, AI is fundamentally reshaping the software development lifecycle by essentially turning reactive tasks into predictive context-aware processes, right? So especially if you look at, for me, from a coding point of view, we have AI-assisted tools like GitHub.
Welcome to this episode of the AEC Engineering and Technology Podcast, the podcast dedicated to helping engineering professionals find technology that fits their needs. Did you know that over 70% of AEC firms plan to invest in artificial intelligence technologies within the next 2 years? AI isn't on the horizon, it's here, and it's transforming how we design, build, and collaborate. From predictive maintenance to risk mitigation, AI is rapidly becoming a force in the AEC space. In today's episode, we're exploring how AI is not just improving operations, but redefining the future of engineering with a focus on real-world applications across the tech and infrastructure landscape. And we're doing it with someone who has a front-row seat to that transformation. Joining me is Srinivas Chippagiri, who's seen AI revolutionize sectors like software, cloud infrastructure, cybersecurity, and semiconductors. He'll be talking about how AI is accelerating innovation across these industries, from automating code and enhancing DevOps workflows to optimizing cloud systems, strengthening security, and even reshaping chip design and manufacturing. Whether you're an engineer looking to level up or a leader aiming to future-proof your firm, this is the conversation you won't want to miss. I'm your host, Nick Heim, and this is the AEC Engineering and Technology Podcast. With that, let's jump into today's episode. It's now time for our conversation of the week with Srinivas Chippagiri. Srini, thank you so much for taking the time to join the show, and welcome.
Thank you so much for having me.
Yeah, absolutely. So it's a little bit of a different flavor to the audience. So Sweeney's background is pretty widespread, and we'll talk about that and other applications that are still relevant to the group here. But I think this is going to be a great episode. So Sweeney, we'll get it kicked off. Could you start off by telling us a little bit about yourself? What sparked your interest in technology and engineering, and how did that path lead you to that current role in working with cutting edge AI applications?
Yeah, so absolutely. So my name is Srinivas Chippagiri. So I've been currently in the backend engineering space for almost more than a decade now. I kind of started off with this keen interest in building things. Like it could be like solving puzzles or like designing systems that could solve real world problems. So over time, that kind of curiosity took over. Finished up my bachelor's in engineering. I chose engineering because that's kind of like a perfect balance between analytical thinking and like creative problem solving. Over the past couple of years, I've been working across multiple diverse sectors. I work for software in the telecommunications sector. I work for software on the healthcare side. I work for software on the energy distribution side. Now I'm currently working at a Fortune 500 company building their cloud infrastructure stuff. I've had a variety of experience, and over the past many years, I would say, I've worked with led projects and involving like complex system design and large scale infrastructure and like automation stuff as well. So as I progressed in my career, I kind of decided to choose cloud computing as one of the areas that I'm very interested in. So I kind of did a lot of my work and research around that area. And AI is the big thing nowadays. Like everyone's talking about it, everyone's incorporating it. So I kind of decided, okay, how do I take AI and cloud computing and then combine them together and kind of build something meaningful? So along the way, I've been kind of doing a little bit of exploring and how can we use AI to solve like complex cloud computing challenges, like operational challenges. And so right now I'm currently focusing on leveraging like engineering and cloud computing. And in addition to having AI kind of help us out to solve certain challenges that we see in the cloud computing space to kind of drive performance and innovation.
So it's a really nice summary for the audience here. But for those who kind of aren't as familiar with the space that you work in directly, could you describe some of the core areas of the technology that your research focuses on, and then talk a little bit more about how you actually chose those domains?
Sure. Well, do. So it's essentially my background is focusing on cloud computing and virtualization. That's been my core area of research. So along with that, that's one thing that I've been working for almost close to, it's like 10, 15, 10 to 12 years now. And over the past maybe year or two, I've been also focused on how AI can use and how we can leverage AI and use it to our advantage. I selected these domains primarily because they are a representative of industry challenges. They're representative of high impact opportunities. So many of my early professional experiences exposed me to the limitations that we have with traditional infrastructure, right? So we have systems that were like either too brittle, they wouldn't perform well under scale, or it's very difficult to secure. So all of these led to the my focus on moving to the cloud native technologies like Kubernetes and serverless computing. So that's something that I've kind of worked with in the past. Technologies like performance tuning and then control network interfaces, and how do you like intelligently scale systems to handle traffics of scale. Over time, with the development of AI, I began taking a look at how can we integrate AI into these systems that we've already built to improve certain aspects of it. It can be like workload scheduling, it can be like failure detection, can be configuration management. And of course, security is a big aspect when you move to the cloud. So now you have all of your data sitting in a cloud where accessible to everybody, right? So we also need to be a little bit cognizant of what we're putting where. And in addition to that, I've also looked at certain areas like how we can improve performance in terms of like when you scale to a multi-tenant architecture. And when you do that, also take it into account like existing frameworks, like security frameworks, like PCI DSS. So all of these research kind of evolved organically from the problems that I'm trying to currently solve, and something that we have also worked with in the industry as well.
So, Sweeney, so what I heard there was it's essentially, applied research to the problems that you guys face day to day as software engineers.
That's correct. Yeah.
Part of which is use of AI. So can you, and we'll just dive into some more detail here. Can you walk us through how AI is transforming software development, specifically like so coding, DevOps, QA, and then any other areas you want to talk about?
Sure. So AI is right now like basically getting into a lot of these areas. And primarily, if we look at software development, AI is fundamentally reshaping the software development lifecycle by essentially turning reactive tasks into predictive context-aware processes, right? So especially if you look at, for me, from a coding point of view, we have AI-assisted tools like GitHub Copilot. We have Christian AI, and all of these tools act as intelligent collaborators, and they help software developers kind of gain the massive productivity boost that they just don't get with traditional tools, right? So when I say intelligent collaborators, they're not just your autocomplete syntax, but they generate fully functional code. They generate suggest like refactoring, and they even offer like the ability to kind of write your own unit test based on the current existing code. So all of that is a huge value add for software engineers, especially the advanced tools that can take a look at what the comments are, what the logic is, or on the software that you've built. And that essentially helps developers such as ourselves and architects such as ourselves to further focus on creative problems rather than the technical problems, and identification of, like, for example, like software challenges like issues and unit bugs become much easier, right? So that's in the software side of things. So when you come down to the DevOps, right? So DevOps is essentially like development combined with operations. So AI helps in observability primarily. So what I mean by that is there are platforms which are AI backed, and they can perform analysis on, let's say, logging and metrics and traces. So what that does is it allows you to detect root causes of failures much faster. compared to spending hours triaging incidents, engineers can now receive precise recommendations and anomaly flags within minutes. Right. So if you look at my own research, which I've done on the system tuning and CI/CD optimization, all of these basically complement with the existing parameters. Like, for example, you might take like Kubernetes pod management or container restarts or any of these technically challenging aspects of cloud native computing. AI can help you basically get to your root cause much faster. Right? And coming down to QA, right? So QA is always a big part about software development. You want things to work as it intended to work. So there are AI-driven test automation frameworks that essentially look at your business logic and they generate your unit tests. They maintain your unit test, and to an extent, they also kind of fix your unit test in case things were to break in real time. They adapt to front end and back end changes, thereby effectively reducing regression. And then now you have your maintenance window drastically reduced from like hours to like minutes, right? So now what happens is these are all reflective of how fast you can ship to production. So this work is now essentially basically translated into building resilient distributed systems, and it helps prevent cascading failures. And it also, there's an area of research where now there's self-healing behaviors. Like if I detect a problem, how do I kind of go back and try to fix that myself? So AI is helping in all different ways so far, to speak.
And from everything you described, I mean, it sounds like it is truly like you said, a co-pilot or an assistant rather than taking full control of the entire process that constitutes software development.
Right. So there's always going to be a human involvement in it. So there's going to be guardrails everywhere. So your AI-driven tools can help you build stuff, create stuff, but then there's going to be a human that determines what the AI built is good as per what we want, and then always we can have guardrails in it.
Well said. And a good segue into our next question, right? So
Uh-huh.
humans still a big part of it, which as we collaborate is part of teams. So we've talked about how AI can help the individual developer, but how is AI helping cloud infrastructure teams better manage their resources and deliver more resilient systems? And can you share an example of intelligible workload management in action?
Yeah, that's a great question. So AI right now is basically revolutionizing how cloud infrastructure is managed. It enables predictive, adaptive, and autonomous operations. So it basically excels at detecting patterns, right, that humans might miss, right? So allowing systems to proactively optimize themselves. So, for instance, you can use AI models trained on historical usage data to kind of anticipate peak traffic in a multi-tenant Kubernetes environment. So, these models now enable the cloud native system to auto like pre-scale pods and then pre-warm caches. So that way you can avoid any kind of latency spikes and thereby improving user experience. And so these are some of the areas that we've personally looked at, and then we've tried to incorporate like nature-inspired like scheduling algorithms. And in other case, for example, there's like anomaly detection that you can use for essentially building a resilient system and hours before an outage, right? So these systems can basically automated like reroute workloads to like a much more stable zone and preserve uptime and also avoid any sort of like an SLA violation, right? So these applications not only reduce operational firefighting, but also contribute to like measurable cost savings through efficient, like, reallocation of resources and reduce downtime, right? So that these are some of the ways in which you can use AI to build more like resilient systems that gives you better performance and better user experience.
And as any engineer knows, right, it's one thing to
Right.
build a solution as like a test or a one-off, but scaling is
Scaling is
entirely
always a
different.
challenge. Yeah. Scaling is
So
always a big challenge for software engineering.
and what are common challenges that organizations face when they're trying to implement AI solutions at scale, and then some ways you've seen them overcome?
Yeah, so I think there's quite a few challenges when we try to kind of implement solutions at scale, especially AI solutions at scale. So, one I can talk about is data quality and availability. So, an AI is essentially just as good as the data that it runs on is, right? So, for example, certain areas like fraud detection using like data sets. So, I've observed that the need for data balancing techniques and augmentation to ensure that optimal performance of your AI model is seen in terms of like accuracy and fairness. So, that is something that we all need to be cognizant of to ensure like data quality and availability. And a lot of companies now run on like legacy infrastructure, right? So they're not necessarily designed to accommodate AI workloads. So when you decide you want to work on AI, then you need to have the necessary infrastructure in place. So that can be your GPU computing, your massive computing capabilities that you have. So traditional workloads is something that you can next like not necessarily use it to build AI workloads. So that is something that I focus on as well in terms of like how to build containerized, virtualized, and systems and use serverless computing to modernize organizational architecture to support like dynamic AI enhanced pipelines. So the second one is like infrastructure is a big thing when you want to scale things. And last but not the least is the lack of explainability and trust, right? So all of these AI models, particularly in like regulated environments, they need to be interpretable. Like I've advocated for like model governance and then built-in explainability metrics, especially when dealing with compliance frameworks like PCI or DSS. So explainability and trust is a big thing about AI, and governance is the last but not the least. So a lot of organizations are now forming AI ethics and governance rules. So that way you can control exactly what the AI is capable of doing and then putting guardrails in place. So that way you can ensure that the model behaves in the way that it should. And organizations essentially kind of can overcome these obstacles like by starting with targeted use cases, right? And establishing like strong ML ops practices, and then creating like cross-disciplinary teams that include like not just engineers but also like data scientists and domain experts. And last but not the least, we also need to take into account AI ethics, so that we ensure that the AI models that we build is going to be fair and unbiased.
So any other long-term changes or innovations that you hope your research will drive in the fields of cloud infrastructure or AI-powered systems?
So the long-term vision for me personally would be to see how self-optimization and self-governance infrastructure works. For example, systems that can adapt intelligently to changing workloads, systems that can detect risks autonomously, and then systems that can comply with security standards dynamically, right? So I hope to like contribute to the development of infrastructure that's not just scalable, but proactively efficient and environmentally conscious as well. So through AI driven scheduling and energy aware workload distribution. So I've explored certain areas like Kubernetes and cloud native orchestration. So I see like real potential in having to use AI to reduce carbon footprints in like hyperscale environments. Right. And once you have things in the cloud, we also need to take a look at security and compliance. So I'm working towards kind of seeing how we can build frameworks where AI models can help enforce like real-time compliance checks and leave audit trails for people to kind of go back and take a look at if they need. And last but not the least is like incident response. Like what do you do when there's an incident and how do you define that process? So the goal is to kind of build a error-free process and to ensure the ethical building of AI systems. So last but not the least, I do want to bridge the gap between operational reliability and intelligent autonomy. So systems can evolve alongside user needs and business goals, and hopefully go towards global sustainability efforts as well.
And Sway, to this point, we've talked more about the technical piece of what
Right.
you guys as software developers do and how it relates to that. So we've also talked about how AI is reshaping how engineering teams operate. So what skills and leadership qualities are going to be most valuable as things continue to change? And then how do you see human AI collaboration evolving in practice?
Yeah, I think that's a great question. I think with AI, what happens is now you have all of these intelligence at your disposal, right? So how does that reshape how engineering teams operate, right? So as AI becomes more embedded in engineering workflows, I think the most valuable skills that we'll see extending beyond traditional coding, we're going to see people that we need to do systems thinking, right? Not just look at how the code works, but think of how a system in a whole is built, ethical judgment, and cross-functional collaboration. So these are certain areas that's going to be like fairly critical. And engineers will need to understand how to design around AI, not just use it, right? So that way we can ensure that there's an alignment with both business goals and responsible development practices. Right? From a leadership perspective, I would say it's all about fostering AI fluency across the organization, encouraging your employees to kind of experiment while establishing guardrails around privacy, around fairness and governance. I've seen like most successful teams embrace AI not just as a tool, but as a collaborator, right? So human AI collaboration is shifting towards a like a co-pilot model. So what it means is AI handles repetitive data-intensive tasks like optimizing deployment pipelines and then monitoring system health or generating test coverage, while the humans focus on creative strategy, ethical oversight, and architectural design. So this dynamic empowerment allows engineers to like work smarter and much be much more productive compared to without AI.
Very well said, Sweeney. And what final piece of advice can you offer to AEC professionals who want to embrace AI not just as a tool, but as a mindset for innovation and long term growth?
Yeah, I think that's a great question to ask because I think my advice would be fairly simple. I would say start with curiosity and start with intent, like not just hype, right? So identify points in your workflow, whether it may be like manual scheduling or performance unpredictability or reactive maintenance, and see how AI can alleviate them, right? So adopting AI as a mindset means investing in data culture, investing in cross-functional learning, and long-term experimentation, right? So build pilot projects, like gather feedback, and iterate, right? So most importantly, I would say ensure that AI aligns with human values and industry context. Right. For AEC professionals, this could mean using AI for generative design. It could mean sustainability modeling or risk detection on complex projects. Right. So I would say AI is not a silver bullet, but when you strategically apply it, it becomes a powerful lens through which organizations can see new possibilities and unlock efficiencies and build resilient future-proof systems.
Excellent. Sweeney, thank you again for taking the time to join us today. If the audience wants to connect with you, ask you more questions about what we spoke about today, what's the best way for them to reach you?
Sure, I think the best way would be to reach me on professional media. I mean, I'm on LinkedIn. Just find me, just Google me, and you should be able to find me there. So yeah, that would be the best way to reach me there.
Excellent. And Sweeney, thank you again so much. It's been a pleasure.
Thank you so much for having me. Yeah.
Absolutely. Until next time. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.